The James Webb Space Observatory, the most advanced instrument for human exploration of the universe, has made yet another significant discovery. The most recent images of Pluto are revealing insights that are both awe-inspiring and extremely thought-provoking, challenging every preconceived notion. We had about this icy planet. Pluto is now revealing itself as significantly more complex and lively, with signs indicating hidden activity, tectonic movements, and intricate chemical structures that challenge current comprehension. It was once dismissed as merely an ice-covered globe on the fringe of our planetary system. These groundbreaking findings have baffled and amazed specialists. The well-known heart-shaped region on Pluto's surface, known as Sputnik Planitia, is central to this new understanding. The frozen shell of what was once thought to be a solid nitrogen ice field is now believed to conceal a vast underground ocean. This enormous reservoir of water, surrounded by thick ice strata, may represent one of the most significant landmarks in the search for extraterrestrial life. Scientists are now pondering the possibility that these secretive depths might be home to microscopic life forms. Shielded from the harsh space environment, researchers are continually taken aback by Pluto's exterior. Majestic peaks covered in ice rise to heights comparable to the highest summits on Earth, whereas wide flat plains remain in perfect condition, indicating that geological renewal occurred relatively recently. Such active phenomena were completely unforeseen for a body previously regarded as geologically inactive. Nitrogen ice shifts slowly as a result of convection beneath Pluto's icy mantle, caused by heat from the planet's core. These processes depict a world that is far from barren, much like molten wax in a lava lamp. These newly revealed images show that Pluto is alive to the brim. Pluto now joins a growing list of icy worlds and moons that may support life beneath their frozen exteriors, including Europa and Enceladus. Despite their vast distance from the Sun, water and organic molecules could interact in ways that spark the chemistry of life, even if more evolved life forms are absent. The detection of microbial organisms on Pluto would drastically alter our concept of habitability in the cosmos, proving that life can flourish in places once thought uninhabitable. Pluto's relationship with its moon Charon is unparalleled in our solar neighborhood. The two bodies, nearly identical in size, exert gravitational influence on one another, resulting in internal heat and dynamic changes on both worlds. Charon has its own mysteries as well. Deep canyons and a distinctive reddish hue imply common origins with Pluto. Charon may be receiving material from Pluto's surface, indicating a chemical exchange that may involve essential compounds for life without the James Webb Space Observatory. None of these incredible discoveries would have been possible. Its infrared imaging allowed astronomers to peer beneath Pluto's icy crust, uncovering details missed by earlier missions. By examining Pluto's landscape and atmosphere, Webb has identified organic molecules and thermal variations, illustrating a more lively world than formerly imagined. Pluto's atmosphere, although thin, is surprisingly complex, consisting primarily of nitrogen with traces of carbon dioxide and methane. It extends hundreds of miles above the planet as a transparent haze. The fragile air surrounding Pluto undergoes significant changes as it moves through its highly elliptical orbit. Surface ice melts into gas as it gets closer to the Sun, forming a temporary atmosphere. This atmosphere refreezes onto the surface as it moves away, resulting in a unique cyclical pattern not found anywhere else in the solar system. These atmospheric cycles offer rare insight into planetary responses to extreme environments. The reddish streaks that run across the surfaces of Pluto and Charon are among their most distinctive features. These areas are thought to be coated with tholins, complex organic compounds formed when ultraviolet light interacts with methane in the atmosphere. Tholins not only give the reddish color, but also suggest prebiotic chemistry. It's a fundamental chemical pathway that could lay the groundwork for life. Researchers are especially curious about how these compounds might interact with subsurface water ice. Could these tholins transport the essential building blocks of life into the ocean beneath the ice to combine with other organic molecules? This fascinating question is one scientists are keen to explore. The possibility that a vast ocean exists beneath Pluto's icy shell is one of the most groundbreaking discoveries about the planet. It's possible that a significant portion of Pluto's interior is occupied by this ocean, which is kept liquid by geothermal energy from radioactive decay in the planet's core. Life thrives in the habitats of hydrothermal vents in the deep sea on Earth. If Pluto's concealed ocean provides similar conditions, it might harbor microbial communities or even more complex life forms, by demonstrating that even the most unlikely locations can support living organisms. Decoding Pluto's hidden depths could revolutionize our understanding of where life can exist. There has been a lot of speculation and excitement since the James Webb Observatory released declassified images and data. What Pluto's depths may reveal about the universe as a whole fascinates both governments and research organizations alike. Pluto was regarded as an insignificant world for many years. But these new revelations highlight how little we truly know about our celestial neighborhood. Around the numerous unsolved mysteries, anticipation grows as more data arrives. The Webb Observatory's breakthroughs are only the tip of the iceberg. To better understand Pluto, orbiters and landers are planned for future missions. These expeditions could provide the first direct evidence of life beyond Earth, confirming the existence of the underground ocean. Some have even suggested sending robot submersibles into Pluto's hidden ocean. It's a monumental engineering challenge that would rank among humanity's greatest achievements in space exploration. As technology progresses, the goal of directly exploring Pluto's depths is gradually becoming attainable. This endeavor has the potential to completely alter our understanding of the cosmos. One of Pluto's most profound puzzles is how it sustains geological activity despite its immense distance from the Sun, in order to maintain a subterranean ocean and drive convection within its icy mantle. Pluto generates sufficient internal heat. This heat most likely comes from Coryn's tidal forces and radioactive decay in its core, which has released energy over billions of years. Pluto's surprising geological activity and persistently hidden ocean may be explained by this internal heat. Although Pluto lacks a strong magnetic field like Earth's, it still interacts with the solar wind in unique ways. A stream of ionized particles is released into space as a result of these interactions, which strip away a portion of its atmosphere. The JWST's discovery of unusual energy and magnetic patterns around Pluto suggests that the Kuiper Belt and its magnetic environment interact. These findings provide a rare glimpse into how small worlds and dwarf planets engage with their stellar surroundings. The first scene only includes Pluto-related revelations. Humanity is prepared to investigate the faraway regions of our solar system that Pluto has revealed, thanks to missions that aim for the Kuiper Belt and beyond. The new opportunities show that even the most far-flung worlds hold stories that are just waiting to be discovered. The line between science fiction and reality continues to blur as technology advances. From autonomous submersibles investigating frozen seas to crewed missions venturing into the Kuiper Belt, Pluto reminds us that the universe is vast, mysterious, and filled with awe-inspiring marvels. Pluto has come to be seen as much more than just a frozen, lifeless speck, once thought of as ordinary. Its active geology, enigmatic atmosphere, hidden oceans, and organic compounds cast doubt on every notion of the outer solar system that has been held previously. The stunning images and groundbreaking findings of the James Webb Observatory have transformed Pluto from a distant curiosity into a central focus of scientific inquiry. These discoveries serve as a warning to us that even in the farthest reaches of our solar system, mysteries lie ahead. Looking forward, Pluto stands as a symbol of hope and curiosity. New missions, cutting-edge technology, and questions about Our place in the universe continues to be sparked by its secrets. Could Pluto harbor life? What else might be hidden beneath its ice? What can it teach us about our own beginnings? The story of Pluto is far from over. We are reminded with each new revelation of the immense scale, hidden realms, and endless wonders of the cosmos if only we would dare to explore them. What are your thoughts regarding the Pluto-related findings of the James Webb Observatory? Do you believe it could support life or hide deep secrets we're not yet ready to uncover? Submit your thoughts down below. And don't forget to sign up for more fascinating cosmic updates. The search for answers to Pluto's mysteries has just begun. With every discovery, humanity's understanding of the solar system deepens. The James Webb Observatory has unlocked access to a realm we once thought we understood, only to discover that Pluto is a complex, dynamic world brimming with secrets we're just starting to unravel. These findings recalibrate our view of Pluto and challenge our beliefs about life beyond Earth as we continue to investigate Pluto's landscape, atmosphere, and hidden realms. Upcoming missions are set to tackle some of the most crucial questions about its potential to support life. Could microorganisms or even more advanced ecosystems thrive beneath the frozen crust of the ocean? Could Pluto's unusual atmospheric cycles shed light on the evolution of distant exoplanets? This ongoing scientific quest is essential for answering these and many other questions, potentially transforming how we approach habitability on other worlds. Alongside the JWST's work, additional scientific instruments and exploratory missions will deepen our knowledge of Pluto. New vantage points will be provided by orbiting spacecraft, while landers and future rovers may collect surface samples. Subsequent missions could directly confirm the subsurface ocean, offering evidence that life can exist in the most unlikely places. With the ability to learn more about Pluto's geology and atmosphere, future expeditions promise not only insights into this dwarf planet, but also revelations about broader cosmic mysteries. As technology develops, we may see the deployment of robotic submersibles beneath Pluto's icy crust, a groundbreaking achievement in space exploration that would make it possible for humanity to investigate one of the most mysterious worlds in the universe with unmatched precision. Pluto's strange and unpredictable behavior continues to puzzle scientists. Despite its remoteness, it produces internal heat that drives geological and atmospheric activity. This heat, generated by radioactive decay in its core, helps explain the movement of ice on its surface and the hypothetical subsurface ocean. This internal heating is also made possible by the gravitational interaction that occurs between Pluto and Charon. Tidal flexing helps maintain geological activity. This extensive investigative effort into Pluto's geology and atmosphere is reshaping our understanding of planetary evolution in the cold realms of space. The fact that Pluto remains so active under such extreme conditions defies conventional wisdom, indicating that our knowledge of what is possible beyond Earth remains incomplete. The ongoing search for life on distant worlds will define the coming era of space exploration, inspired by the JWST's discoveries. The search for the conditions necessary for life to exist in the universe is just getting started, and it could lead to microbial life on Pluto, secret oceans on other moons, or even environments that are habitable beyond our solar system. As we broaden our horizons and examine new celestial bodies, Pluto remains a key focus of scientific research and thoughtful exploration. In conclusion, the discoveries made by the James Webb Space Observatory are only the beginning of humanity's quest for cosmic understanding. Pluto, once seen as a frozen, lifeless outlier, is now recognized as a vibrant, active world filled with unexpected phenomena. Pluto's surface, atmosphere, and hidden waters may hold answers to some of the most profound scientific questions as further research is carried out. However, its mysteries are far from being resolved completely. Our understanding of planetary processes, the origins of life, and the dynamic nature of the solar system is expected to grow as a result of the ongoing exploration of this faraway planet. We are encouraged to look beyond the familiar with each New discovery because it challenges our assumptions. In the end, Pluto exemplifies the wonders that lie ahead in the farthest reaches of space. It serves as a reminder to us that even the tiniest, most remote worlds can provide remarkable insights and pique our insatiable curiosity.